Hey folks, Quilly18 here, and welcome to part 3 of our tutorial on how to build a web application that can communicate with Unity, or a Unity application that communicates with web server, whichever way you want to think about it. This is the final part of this little mini tutorial, but the idea is to follow this up with more content and continue to build this. But since I had tried so many times to start this project in the past and the scope became really not great for a tutorial, I thought this might be a better approach to things, and I think I finally hit on a winner. So it's going to be a bunch of these short little focus tutorials on particular aspects that we can use to expand this Unity game / web server interaction. So in the last episode, what we did is we set up using Express the response to a web query that would return some sort of data in a JSON formatted string. So the idea being here that the Unity game will ask the server for some data of some kind. The server will then go into its database and, interact with things that interact with other players in some way, and it will return some sort of data and send it back to Unity. I went ahead and added a little bit of extra stuff to this data object just to show that we can do more. So what I did here is I added in an array. So this dummy data that we had before is going to return a user ID, which is actually it's going to be getting from the request. It's going to supply this username, win, losses, and it's going to have this random array of stuff. This array is going to have 3 objects inside of it with various values over here. And that's going to return that, and it actually, there you go, refresh this page, and there we have it. So my awesome ID is what I typed in there, so it's bringing it in over here. And it's got the rest of the data. All right, we're done there. We are now going to go ahead and work in Unity. Now, I have imported a file here into our project called simple JSON. To the best of my knowledge, there is not just a simple JSON parser in the .NET, the C# that is available with Unity. I think it might have access to the JSON serializer code that is available in .NET, but that's not actually what we're looking for over here, because I want to keep it super simple for what's going on. So there's going to be a link down in the doobly-doo where you can get this simple JSON file. It is just a single file that's going to do some stuff, so you can take a look at that from there. But for now, for just a moment, let's go ahead and ignore it. So if we're going to run some code in Unity, well, there's a bunch of different ways of doing it, but what I'm going to do is I'm going to create an object in the scene over here, and it's going to be responsible for running some code, and we'll probably just have it export some stuff to the console or something like that. So let me just go ahead and make an empty, we're going to call it server talker. That totally makes sense. And I'm going to add a new component that I'm going to call server talker onto that. There, perfect, beautiful. I'm going to open this in. Okay, right, it still has the Gesem folder open. Oh, that's actually quite convenient. All right, I actually didn't know. Oh, no, that's a new one. Do I have 2? Oh, I do have 2 copies of Visual Studio Code. I actually didn't know how Visual Studio Code would respond to me doing this. This is perfect, because I can check the server code over here, and I can look at the client code over here. So what we're going to do here in Unity is very simple. In the start, make a web request to get info from the server. This will be a text response. That text is actually JSON info, so we need to parse that into something we can navigate, and then output some stuff to the console so that we know that it worked. Okay, so 3-step process over here that we're going to get started with. Now, the first thing we have to be really conscious of as we do anything with networking whatsoever, and it's not just with this web request that we're doing, any networking whatsoever, even with, quote unquote, real-time WebSockets and things like that, is there's always some delay, some waiting when it comes to networking things. So you never want to have your application stall while you're waiting for it. You want your application to keep running, and then whenever there is an update, do the thing at that time. Because even if it's really, really, really fast, likely you're still going to like drop a frame or two while you're waiting for that internet update from some form. And it'll be more than just a frame or two likely with the web request style that we're doing here, at least if it's not running on your local computer. On your local computer, it will be blindingly fast. But online, I mean, there'll be a few milliseconds delay, and that is too much. So we're going to use a coroutine over here. You guys know I'm not usually a fan of coroutines personally, just because the way that it gets done, I feel like there's a lot of behind-the-scenes magic that is going on. I don't like those kinds of shenanigans, but this is going to be an excellent use case for that. So we're going to define a coroutine here. Enumerator get web data, and we'll need some sort of web address. This is the address that, the same thing as what we do by typing it into the toolbar of our web browser. We're going to run that. We got a bit of an underline over here because it doesn't like that we don't have our yield return of any kind. That's the only reason why we're getting a bit of a complaint over here. So we'll get that resolved in a sec. What we want to do is we want to use Unity web request, which is built into Unity to just, all it does is go to the web and yoink a web page. We do need to, using Unity engine.networking. And hopefully this isn't deprecated by the time we get around to it, because there was an old www object that you could use, but I think that's deprecated. And Unity, I don't know, it feels like every 3 months they decide to change everything about their network code, but hopefully this will live a little bit longer than that. So now we should be able to do Unity web request. Excellent. And what we're going to do is we're going to use a static function to do it, and that's going to be a get. Notice there are a few in here. Remember in the last videos I talked about the different HTTP verbs? Notice there's a get, there's delete, there's head. These are all actually, there you go. Here's a list of HTTP verbs that are possible for doing various things. But we are going to use a get over here, and all it needs is an address. Now, obviously, we're not going to want this hard-coded in our real application. I mean, conceivably, we, have some sort of const string, with some sort of server name and information like that we're pulling in there. But for our purposes, it's going to be perfectly fine for us to just say localhost :8000. This is the same address as we were just typing into our web browser. Oh, that's actually not true. Hold on, I'm lying to you, because just putting this in like this will say, hello, this is your Unity WebGL game. Instead, what we're doing is this over here. So let me copy this into here. And we're going to have, some sort of ID. Let me do it as a string my ID. Like that. There we go. So it's going to get this request. And then what we can do, because we're in this coroutine, we're going to wait until that request completes. www.sendWebRequest. Done. So this is going to open or access this, same as if you do it in your web browser. And then it's going to, this whole coroutine is going to wait until the response comes back, and then it'll continue to execute over here. But meanwhile, your Unity application as a whole will just continue to be doing stuff. So we can do an if. So this is going to have a results field over here, which is going to return a status code. So we can say, well, I was going to check for success, but I guess I can say if it's not equal to a success, which would be Unity web request.result.success debug.log error, something went wrong, and www.error over here should have that message. Good. I guess I could have had maybe an is error. Oh, we'll check on that. But for now, we can just have it do this. And that should tell us what the error message was. And then what we'll do is we'll return and bail over here. Oh, yeah, I can't just return. Is it return null inside of a coroutine? I don't know if there's a way to bail out. I guess then we'll just have an else. That's going to be fine. Again, I don't do the coroutine stuff a lot, so some of this syntax isn't uploaded into my brain consistently. So here we got what we're actually looking for. We got our JSON object. So first, let's just go ahead and debug.log, and we're just going to spit out to the debug log and see what it looks like just in terms of the raw stuff. So it's www, apparently it's download handler .text. There might be a couple of ways to access it, but let's give that a go. Boop, 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 boop. So all we have to do is actually call this. So we're going to call start coroutine, get web data. And it always throws me off that it actually looks like you're calling the function like this here, which is because of the way it returns. I don't know. The IEnumerator stuff to me is bizarre magic. Oh, right. So we actually want to pass the address here as the address, and then our ID, which will be my awesome ID. There we go. Fix my params, and then get address. Oh, that's why I got confused, because I yoinked this this parentheses. I was like, something went really weird. Okay, so we're gonna get the web data from this thing over here. And again, in a real program, you're probably going to want to go and abstract that even more, so you're not routinely typing in the full web address in your commands. But for now, this is going to be okay. All right, I think we can run this. Now my server is definitely still running, because there you go. Okay, that's working. So if we go into Unity, if I can find it, where is it? Right over here. Compile the scripts. Shuka, shuka, shuka. And again, I have this the simple JSON script in my project. We're not doing anything with it yet. So if I hit play, there we go. Look at the console log. There you go. My awesome ID, username Quill, it's all in there. Beautiful. But right now it's just a string, right? And so all this information would be hard for us to deal with. Now, if our server over here returned a very simply formatted string, we could probably just write our own little parser for it to try to break out the data. But the JSON stuff, all right, we could do it, but it would be some work. But that's where simple JSON comes in. So simple JSON is just this script. There's actually a few different takes on this very thing online. But this one here by Bunny83 has been in use for a long time. It's on the Unity code snippet wiki. And as far as I know, people have had great success and great fun with this bad boy over here. So we're gonna go ahead and use that. So if we go back to our server talker, so what we're gonna do here, we'll still spit out the text to the debug log directly, just so that we have that as a reference is I guess the word I'm looking for. But then what we're gonna do, let's return it. Oh yeah, here, hold, that's the other thing. Yeah, I guess because this returns immediately. So if we can't do things over here, right? Anything over here will happen immediately before the web request comes in. So I guess we move this logic down over here. Okay. I guess, and that's the thing. Again, with coroutines, you have to remember, this will return / continue immediately, but the coroutine will take several milliseconds to actually get a response from the server. The thing we could do, though, is actually, hold on. Yeah, let me do that. Let's make a function here called process server response. This is going to be a little bit cleaner. So we're going to get a string. It's going to be raw response. There we go. I like this. I like this a lot. So we're going to call this with the text in here. Boom. Beautiful. Okay. So now what we want to do is we want to make use of our JSON parser. So we've got it in here. It's got a namespace. So I think we're going to have to say using simple JSON, or we can just do it the long way, which is probably going to be fine. So we're going to say simple JSON.parse the string, which is raw response, and this returns a JSON node. Well, I was going to say JSON node, but it won't know what this is. You know what? I'll switch to a using. Let's do that. It'll save me typing some words. Using simple JSON over here, which is coming from this. There we go. So we're gonna parse the JSON. It's gonna be a node. So the idea is the node here is a tree, right? If we go back to this over here, so there's gonna be a base node, and that node might have other children as part of it as we go down. We don't actually have to worry about how that's organized internally. It actually works really, really, really simple. So we can do something like debug.log username is equal to node username. And then we can say misc data. And for that, we're going to use, we're going to ask for sum array. We're going to ask for the second entry, or the 1th entry in this array. So sum array, the 1th entry, which is going to be the second thing in here, will be bar with a value of 7.1. So name, that is what I called it, right? Yes. Name plus, oops. Plus value, like that, da 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 da. So let's run this in Unity. There you go. Username is quill18, and the misc data says bar is equal to 7.1, which is correct. And I know this is like a simple example, right? Because we're just serving up what is in fact just some static data in here, and we're not actually doing anything with this. But we could do anything with this, right? So we've got some, player data dot set bar, which is going to be equal to the value of what is the bar over here, or something like that. Or we could, get some sort of user interface text set UI text dot, whatever to whatever. Like, we've got the data. What you do with it is a whole other whatever. We are going to try to come up with more videos and more examples and actually show you some use case for this, but hopefully you can imagine. So imagine, for example, imagine you were running something that felt like it was in a big persistent universe. Again, not anything that has like real time moving around. So maybe this isn't well suited to like an MMO where you can actually see people walk around in real time. Or this could operate in addition to that in various things. But let's say players can organize shops and interact with shops and do various things like that. But you wanted some sort of central, what's the word I'm looking for? Like authority as to how much value people had, how much, actually, even something like, imagine something like a Diablo-esque kind of game, where the actual gameplay, right, you find a monster, you kill a monster, you do that, is all handled on the client side. Because maybe you're a small developer with a limited budget. You can't handle a server that does, like, handles all the gameplay and simulates the AI of all the monsters and does all that kind of authoritative stuff, right? So instead, people play the game on their own clients, but when they go and interact their stash or interact the merchant or update their gold total, that all gets sent back to the server or just saves that at the server. Sure, there's Steam Cloud integration and various things like that, but maybe, first of all, maybe you're doing a cross-platform game and you want to have your PC, console, and mobile games all syncing to the same central server. Well, you do it this way, for example. That's totally viable. Remember that not everyone's online all the time, and what implications might that have for your game, etc., etc., etc. This could be as simple though as synchronizing a high scores list. And really, that might be the simplest thing. How do you get a centralized high scores list for your game where you can compare against every other player that's ever played? Well, here you go. Now, then there's a whole discussion about, well, how do you prevent people from cheating? Because obviously with this, anyone can send any data to the server at any given point. And there's a bunch of different ways to do that, depending on what kind of data and how authoritative the stuff from the client is supposed to be, yay or nay, and how much code you want to write on your server. For example, if someone's trying to buy $1 billion vehicle, and they only have $3, well, obviously, you're going to send back, you're not allowed to do that. Now, people might be able to just, spoof their own client so that they still get to drive around in the super fancy car, even though they don't truly own it on the server. But if that's not impacting other players, right? So it depends. Like, so all the use cases are all unique. They're radically different from one another. The solution for one doesn't necessarily apply to another. And it really depends. It really depends on what kind of game you're doing, how much you can trust, and so on and so forth. But this is a problem that just exists regardless. Even if we weren't doing this sort of web-based, send a request, get a response, right? Even if it was just a real-time socketed stuff, the same thing applies. What's to stop someone from making a fake client that sends doofy data to the server, or when it gets data back from the server, the ability to make a fake server that sends doofy data to your client so that you're working, in a fake environment. I mean, even the big guys, right? Even stuff like Blizzard with World of Warcraft, people made their own private World of Warcraft servers. They created their own server software, basically, that WoW clients could connect to without having to pay a Blizzard subscription. I mean, it's not the same content because a lot of the gameplay in something like World of Warcraft is handled on the server side. So it just comes out to whatever the people could actually create with their own private servers in terms of content. But that exists. That's totally a thing that just exists. And there are various like cryptographical kind of things to avoid more and more parts of it. But ultimately, it's not completely avoidable. So that is definitely beyond me. That is a discussion that I am in no way whatsoever authorized to even approach, because it's very, very, very heady stuff. But you can at least keep the basics of it in mind, so that there's not some easy and cheap way of doing it. Or at least if it's anything that where you're storing stuff on your server, you're gonna have to maybe put in some work to make sure that people can't just send you absolute BS. And that how that happens, I'm not sure. Again, because it's absolutely on a game by game basis. There's no one size fits all piece of advice I can give you. It really depends on what you're trying to accomplish. So, but with those caveats in mind, like, you can already take what we've done here and do pretty much anything with it. We can send some data, and that is a simple version of sending data. Rather than a get, you'll want to look into a post if you're trying to chunk your data from the client to the server. If you're sending chunkier data, you're not going to want to do it as a get like this. You're going to want to do it as a post, and it's a slightly more involved thing, because with a post, you're still putting in an address. How do they actually format it here in Unity? Actually, this post, yeah. So you're sending in you're still sending in the URL as the address, but then it's got this post data over here, which is a string, but it's going to be a URL encoded string, and it doesn't get sent as part of the actual web address. It gets sent as secondary data that's bundled in the request, which bypasses all kinds of like size limitations and things with the address data. But it's not a world of difference in terms of that. And yeah, there's no reason. So we're sending from the server. We're sending back text data, JSON formatted text data, but there's no reason the server can't send back images or all kinds of binary information as well. And in fact, that is one of the ways that you can avoid the easiest sort of spoofing of data and things like that, if the information going back and forth is encoded in some way. But keep in mind that the encoding, the encoder and the decoder will be available in the user's software itself, right? If someone goes and decompiles your game software, they'll be able to find your encoding and decoding data in there, and they'll be able to reverse engineer their own sort of thing. But then all of a sudden the ease of doing it becomes quite a lot tougher, and it's going to be less casual. Someone's going to have to be slightly more dedicated to the process to be able to do it. But yeah, you can send absolutely anything back and forth between the server and the client. We've covered it in 3 videos. You can literally do anything. But I am hoping to continue this and look at the next thing I would like to do probably is look into the actual database stuff on the server side, probably doing something like MongoDB, so that this data here, rather than being dummy data, we will actually read it in from a database and be able to update some information as stuff happens. Thanks a lot for watching, folks. I'll see you guys next time. Bye-bye. This episode is brought to you by the incredibly awesome and incredibly patient people who support me over at patreon.com/Quill18creates. And that includes our mic check supporters. We got David Crew, Ilunda, Julian Gallic, Thomas, Jeff Fellows, Tiburon, Pavel Zdanov, Michael McClintock, and Steven Stager. Again, thank you very much for your patience in finally getting this thing out, and I hope you guys do make it to the Love and Dare streams as well when they happen. The last one was pretty epic. Still working on the post-mortem for that. Stay tuned.